so I'm just going to go through the practice problems now. So number one says use standard SI units to express each of the following measurements. So SI units stands for International System of Units. I think it's because it's French or something is why it's kind of backwards, but not sure. So that's really talking about kilometers, our metric units. Good thing about physics in Canada is we use the metric system, not that stupid imperial system where you have to remember how many units, like feet or in a mile, all that kind of stuff. With a metric, it's pretty straightforward. It's all factors of 10. All right, so the way we do this, and if you haven't found it yet on your formula sheet, you've got these prefixes, right? That say, millo is something you're probably like a millimeter or centimeter, and it says 10 to the negative 3. What that means is that away from the base unit is 10 to the negative 3. I'll show you what I mean by that. So if we go back to this one and we want to go, let's say, kilometers to meters, well, go to your thing. So kilo is here, right? Kilo is 10 to the 3. And what that means is that if I want to get from kilometers back to the base unit, back to meters, I just need to multiply by 10 to the 3. So this is 2.7 times 10 to the 3 is going to give you 2,700 meters. All right, so that's kind of what that means. The other easy way of thinking about it, though, is times 10 to the 3 is going to mean that you're just going to move the decimal place 1, 2, 3 times, and you end up with this, right? So it was here, now it's 1, 2, 3 times over. So just a different way of thinking about it. All right, so if we have 0.56 kilometers, I'll put this over here, so A. So we started out with 0.56. All you're going to go or do is the exact same thing, really. You're just going to move this 1, 2, 3 times. So this was in kilometers. So our answer is now 560 meters. So I'm just going to put all the answers down here. I'm going to stop at ones that might be confusing. So for E here, or take a second to see if you got A to D right. But for E, this might be a symbol that you've never seen before. This stands for micro. A little kind of looks like a U. And that's right here, right? Micro, 10 to the negative 6. So all you do is take our original number. And there's two ways, like, I know it's times 10 to the negative 6. Remember, we moved the one up top here. We moved our decimal to the right. This one we're going to move to the left because it's to the negative 6. And that's the only way it makes sense, really. If you think about it, if I've got like 961 of these really small things, then I'm going to have a lot less of a bigger thing like a meter, right? So it only makes sense that you're going to move it to the left. If you moved it to the right, you get an answer that didn't make any sense at all. You'd get like a huge amount of meters in 1 micrometer. So with a reason test, that just wouldn't make sense at all. So it's going to go to the left, and you're going to move it 1, 2, 3, 4, 5, 6 places over. And you're going to get a really small amount of meters, right? Which makes sense. Okay, I'm going to keep going with the other ones. So this is another symbol that you might not have seen that's not on your formula sheet. It's called an angstrom. And an angstrom doesn't show up here as one of our units. But what it is actually would fit right in here. It's times 10 to the negative 10. So you end up with this really small number, right? And normally we want to put this into scientific notation too. But I'll do that on the ones down here. Okay, I'm going to carry on with the last two. All right, so there's the answers for that one. Go ahead and check your answers to make sure that you've done it correctly. Number 2, get a new color pen. For each number below, determine the number of significant digits. So for A, there are 1, 2, 3. So 3 significant digits. For B, there are still 3 significant digits. The 0 is significant there. They put that there for a reason. So there's 3. C, there are only 2, right? Starts from the first non-zero number, working your way to the right. So there's only 2 for that one. D, there's 2 again. E, there are 3. F, there are only 2. And then G, we're in another room here, there are 4. All right, 3, use scientific notation to express each of these numbers. I'm just going to actually write them all down to the right here, and you can check your answers. So I just wanted to draw your attention to D here, where it says 7 sig digs. It had to tell me directly there that it only wants 7 sig digs in my scientific notation answer, because these 4 zeros in the end, they could be significant. They could just, like, this answer could just be that accurate, right? But yeah, but they're telling you in this question that it's not, that we're only confident with the first 7 significant digits. So it had to be explicit there. Okay, carrying on. Okay, so there's your answers. Take a minute to pause and check to see if you were right. And moving on to number 4. Okay, again, I'm just going to pop up the answers here and then you can pause it. All right, so again, just pause it and take a look at these answers, see if they match up with yours. So number 5, make the following calculations and express your answer in significant digits. So for these ones, we really just got the big question is, are we adding and subtracting, or are we multiplying and dividing? Because they have 2 kind of separate rules there. Okay, so for part A, you can kind of see I brought my calculator up here. Just add them all together, and you can see that my answer here is 400. Hopefully you can see it's kind of small. 493.03. So now, since we were just adding, right, this is where we're looking at just after the decimal. That's all we really care about with the adding and subtracting is those decimal places. So our smallest number here was 29.2. Only had 1 decimal place. So our answer can only just have 1 decimal place. So in the end, this would be 493.0. That'd be my answer, right? Okay. So I'm going to carry on to B. All right, so for C until H now, they're all going to be kind of the same rule. They're all multiplying or dividing, right? Now for this, all we have to do is look at our lowest significant, or lowest sig digs. So in this case, for C, 2.6 only has 2 sig digs, so our answer can only have 2 sig digs. So if we look at this on my calculator, I've got 2.6, and then you can see there's a little tiny dot there. That means times 42.2. And my answer is 109.72. So I'm just going to write down the whole thing. So that's my answer if you multiply them. But I can only have 2 sig digs. The only way I can do that is by writing this thing in scientific notation. So I got to move this decimal place 2 times to the left. So this becomes, let's put like an arrow, 1.1, because it rounded up to a 1, right? That was a 0, it rounded up to a 1 because of the 9. So 1.1 times 10, and I move the decimal place twice. So times 10 to the 2. So you can start to see why scientific notation needs to happen now, because we have to. It's a good way to write it with our lowest sig digs. Okay, so I'm going to go ahead and do down to H. Okay, so there's your answers for up till H. Now, I and J, they look a little bit different. It goes 3.5, and then you can think about this as like times 1 divided by 2 or times a half. Really, what this is like a times a half is the way we're going to think about it. And in this case, then, if it's just times a half or times 1 or something like that, you're looking at the data. So this 3.5, that's your lowest significant digits. We're just cutting it in half. So this half, this can't count as our significant digits. So it wouldn't be 1 significant digit because there's like a 1 and a, divided by 2, which are both only 1 significant digit. We're going to look at the 3.5. So our answer should have 2 sig digs. Same with this one. Our answer should have 2 sig digs. So I is going to be 1.75, so 1.8. J is going to be 2.45, so 2.5. Okay, so hopefully you guys found this helpful. That's going to be it for that lesson, so I'll see you guys in lesson 1.